Hi everyone. Today we're going to learn about Boyle's law. So this is one of the gas laws that we're going to learn. We're actually going to learn 4 laws altogether. Okay, so first one, Boyle's law is named after Sir Robert Boyle, born in Ireland, 1627 to 1691 are his dates. So he's sort of famous for creating the first vacuum chamber air pump. This one I find particularly interesting here. He's the first prominent scientist to perform controlled experiments, and he published his procedure, apparatus, and observations. So when you have to write your procedures and observations, you can blame Boyle for that. But I find it really interesting because prior to this, no one really talked about how they did something or what apparatus they used, what their observations were. So when he started to do this, this allowed people to recreate his experiments. So it's sort of that sort of the nature of science, how you're sharing resources, sharing information. So it's an interesting step for science here. He helped create the Royal Society in London. So this is a group that's still running in London. You can Google them. They do lots of educational things for science. And so this was a group who met once a month just to talk about science. So again, this group's still in existence today. Okay, so he experimented to discover the relationship between pressure and volume of a gas. So remember, all these formulas that we're looking at, these are all just for gases here. So he discovered the pressure that's supposed to be an if. That if pressure is increased, the volume is decreased. So what this means, as pressure goes up, volume goes down. Which makes sense here. So if we look at these balloons here, this would be my initial balloon here. And then if I look at A, so how would you get A to become compressed like that? You would have to increase the pressure, right? So if we increase pressure, that means the volume went down. B is the same size as the initial one. For part C here, volume here increased, right? So what do we know happened to the pressure? So pressure will have decreased for this. The way if you were in class, I would have had you like hold your hands up. So you can do right now, hold your hands up like you're holding a balloon, and just close your eyes and just think to yourself, increase the pressure on that balloon. And automatically everyone's hands would have gone in to show that the balloon was getting smaller. So increased pressure decreases the volume. Now this is an inverse relationship. We talked about inverse relationships already when we talked about IMFs and vapor pressure. But what this means then, pressure varies with 1 over volume. Okay, so an inverse relationship. So as one goes up, the other one goes down. So this is our formula here. So make sure you have this boxed in your notes. You need to get familiar with the gas law formulas. Now you'll notice that we've got 2 different situations here. So we've got our initial conditions on this side, this is the 1s, and then our secondary conditions on the other side, those are the 2s. Now, temperature is missing from this equation. So what that means is that we can only use this law when the temperature is held constant. So if the temperature is going to be changing, you can't actually use this law here. So this is you can only use Boyle's law when temperature is constant. Okay, so we're going to go right to working through a problem here. So question, if 3 liters of gas is initially at a pressure of 1.0 atmospheres of pressure, what would be the new pressure to cause the volume of the gas to become 0.50 liters? So I find sort of the most difficult thing with these is just that people sometimes have a hard time figuring out which variable is which. So you want to sort of go back to what you know about problem solving in math. And so you want to write yourself a variable list on the side. So just start out doing this. It's important. It'll help you. And then you can just start placing things. So 3 liters of gas initially. So that's my first volume, 3.0 liters here, is initially at a pressure of 1 atmosphere. So 1.0 atmosphere. What would be the new pressure? So new pressure is our question mark to cause the volume of the gas to become 0.50 liters. So as you can see, you just fill it in step by step. So don't become overwhelmed with the question. You just want to go through, read it really carefully, and just plug in all your values here. Now you've got a formula. P1V1 equals P2 V2. So you're solving for V2. I usually just get in the habit of solving the one that I'm looking for. Now, how would I get rid of that P2? Yeah, because you want to get V2 by itself. So you would end up dividing by the P2. So I'm just going to rewrite my equation here. So V2, and these ones are going to cancel. V2 is going to be equal to P1V1 over P2. And then you're just going to sub in your values, right? So 1 times 3 divided by 0.50, and then you get an answer of 6. Now, how many sig figs can you have though? You're going to look at all your numbers here. You've got 2, 2, and actually they're all 2 here. So you need 2 sig figs here. So 6.0, and then don't forget your unit. Your unit is going to be liters. Okay, so 6.0 liters for that question. And then and you always want to sort of do a double check and make sure that your answer makes sense. I mean, science teachers, we talk about this all the time. No one ever does it, but try to do it. You know here that you started out with 3 liters of gas, and then the pressure is decreased. So if the pressure is going down, that should tell you that your volume has to go up. And it did go up, so you're good there, okay? Okay, so this one, if you want, you can pause the video and try it on your own, or you can just follow along here. So a gas eventually ends up having a volume of 42.1 liters and a pressure of 742 millimeters of mercury. If the pressure was initially at 101.4 kPa, what was the initial volume? So again, we're going to write our variable list, P1V1, P2V2. Excuse me. And we're just going to start filling in our values here. So it eventually ends up having a volume of 42.1 liters. So this is going to be our secondary condition, and a pressure of 742 millimeters of mercury. If the pressure was initially at 101.4 kPa, what was the initial volume? So in this case, you are going to be solving for V1, but right away, hopefully you've noticed there's a problem with this. So what's the problem? Yeah, so our units of pressure are different. You cannot solve this having different units of pressure, which is why at the start of this unit, I had you practice converting units. So here you can either change the millimeters of mercury into kPa, or you can change the kPa into millimeters of mercury. It really doesn't matter. I think in your notes, if you had the note package, let's check here. Yeah, I think I gave you, I think I converted in the notes to kPa, so let's go ahead and do that. So we're going to convert this 742 to kPa. So kPa equals 742 millimeters of mercury. Now, millimeters of mercury goes on the bottom, kPa goes on the top, and the conversion factor between these, you have to memorize these, is 760 millimeters of mercury for every 101.325 kPa. And that means your millimeters of mercury is going to cancel out here. I'm just going to do the math here. 101.325 divided by 760. Okay, now again, don't worry about the sig figs here. You're just going to carry quite a few at this point. So 92.9252 kPa. Okay, so now I've got that. So now I've got both my pressures in kPa. So now I can go ahead and solve for V1. So my formula P1V1 equals P2, V2. You're solving for V1. So V1 is going to be equal to P2, V2 divided by P1. So if we sub in our values here, we've got 98.9252 multiplied by V2, which is 42.1, all divided by 101.4. So if we do the math on that, so what is this? Times, sorry, 98.9251 times 42.1 divided by 101.4. And so you should get an answer of 41.07. But you want to look up here to figure out your sig figs. So 433. So your sig figs, you only can have 3 sig figs. I ran out of space here, so I'm just going to put my answer here. Is going to be then 41.1. And your unit is going to be liters. Okay, so 41.1 liters for that one. Now, these problems are all the same. They're very similar. You're always going to be given 3 of the variables and you solve for the 4th. So fairly straightforward that way. There are a few tricks just in how the questions are worded. So the math is simple. The wording of the question can be difficult for people, so that's what you need to practice. You have the answer key for this already, so please work through them. Your assignment is going to be exercise 4 in the work exercise package there. Again, message me if you're having problems and we can